This session is about modularity. So in software design, modularity is an important concept. So modularization, so it's a process of dividing a problem into separate tasks and each with a single purpose. So when we have a task, when we have a scenario to solve, we divide it into separate tasks and each task with a single purpose. So we might have to develop an application for a particular scenario where you have to achieve several purposes. So might be a complex scenario. So this modularization is really important, where you can divide the problem into separate tasks. And once you divide it to separate tasks, each task focus on a single purpose. So when the problem is defined, so we have to identify 2 points. We have to identify the processing steps to be performed and also the activities. These activities are then grouped together to form more manageable tasks. And finally, those will become the modules. So we have to group the tasks, and maybe each group, a particular group, will focus on a particular purpose. So benefits of modular design. So let's see what are the benefits, because there should be a particular benefit in order to do these kind of things. And one is the ease of understanding. So it's really easy to understanding a particular piece of code or piece of application when it is divided into particular sections. So we know this section is responsible for a particular task and another section is responsible for another particular task. So each module should perform just a single function. So it should be a meaningful function or a task. And code reusability. So that's an important in software design. So if you are duplicating your code everywhere in your application, it is not a good practice. So the best practice is you have to reuse the code. So when you have a modular design, so when you have the modularization, you have a reusable code. So the modules used in one program can also be used in other programs. So reusability is one advantage of the modular design. And the efficiency of maintenance. And once you develop a software, so in industry, when you develop a software for a particular client, you should provide maintenance as well. So the software will run for maybe 10 years, 100 years or something like that, 20 years, 100 years. So there should be particular maintenance. The maintenance support is also a critical thing. So the efficiency of maintenance can be achieved by using a modular design. So let's see how we can do it. Each module should be self-contained and have little or no effect on the other modules within the program. So if we change one particular module, if it causes the full application to be affected or changed, then that's not good. So the maintenance cost will be high. So it's not efficient. So if each module focuses on a particular task and a change done to that module is not that much affected to other modules, then that's really easy. So the efficiency of maintenance is also an advantage of modular design. So each module should be self-contained and have little or no effect on other modules. So sometimes it's not possible to have a scenario where it has no effect. So in that case, we can have minimum effect on other programs. So let's see an example of sorting 3 numbers, 3 characters. So first we design a solution algorithm that will prompt a terminal operator for 3 characters. Accept those characters as input, sort them into ascending sequence and output them to the screen. So it's an easy example. So algorithm is to continue reading characters until XXX is entered. So once XXX is entered, the program will quit. Solution. The solution looks cumbersome and involves some repetition of code. So it is a candidate for modularization. So solution with modularization. So we can have process 3 characters and first read 3 characters and do while not. So we have a condition that we should exit the program if we have XXX. So we can use this line to validate that. And the most important part, sort 3 numbers, output character 1, character 2, character 3, and read 3 characters and undo. So these things which we have covered in previous sections. So in the next example, we'll cover the process temperature. Every day a weather station receives 15 temperatures expressed in degrees and Fahrenheit, and a program is to be written that will accept each Fahrenheit temperature and convert it to Celsius and display the converted temperature to the screen. After 15 temperatures have been processed, output all temperatures processed from the message screen. So we have printing numbers, set count to 0, do while the count is less than 15, and we have the temperature handling part, the process temperature, prompt for temperature and get it and calculate the temperature in Celsius and display it and increase the count. So you can see the rectangle in red. So it is the process temperature. So it's a, we can have it as a particular module. So in this example, we have the same code, and we can see we have replaced this piece of code which is in the rectangle with the word process temperature. So if we want to, so it's as a module, the process temperature is a module. So we replace that with the line process temperature. So if we want to see what is happening inside the process temperature, so we have it available here. So we just replaced this piece of code with process temperature in the following slide. So we have this one, process temperature, and the process temperature module is available separately. So here we can see we have achieved modularization. So after we have a process temperature module, and in case if another program wants to handle the same scenario with temperature, they can use this process temperature module in their program. So the reusability of the code is achieved via this aspect. So if we go back to the advantages of this, ease of understanding. So it's possible, easy to understand, we know, because the code which is related to handling the temperature is available as another module, so you can easily identify. So if all the logic is inside one piece of code, it's difficult to understand. So we have a nice way of organizing the code. And the code reusability, if there's another application which needs to use the particular code, they don't have to use the whole code. Since we have it as a particular module, they can use that module. And ease of maintenance. Each module should be self-contained and have little or no effect on other modules. So if there's a particular change to be done to the temperature handling part, so they can do that change in the the process temperature module. So it will, the whole application logic will be updated from there. So in contrast, if we have it the same logic everywhere duplicated in the code, then when there's a case for maintenance, we have to update the full code. Maybe it's million lines of code. But if we have it in a particular module and we use the reusability, it causes the efficiency of maintenance as well. So as a summary, we discussed about modularization. Modularization is the process of dividing a problem into separate tasks and each with a single purpose. So in our example, temperature process temperature, it handles a particular purpose, a single purpose. So ease of understanding, reusable code, efficiency of maintenance. So that's the end of the session.